Welcome to Crashcast Java, your go-to podcast for all things Java. I'm Victor, and today we're joined by our resident Java expert Sheila. We'll be diving into a fascinating topic. Is concurrent HashMap really thread-safe? Sheila, why don't you kick us off with a brief introduction to concurrent HashMap?
Thanks, Victor. Concurrent HashMap is a thread-safe implementation of the map interface in Java. It was introduced in Java 5 as part of the Java util.concurrent package, but before we dive deeper, let's clarify what we mean by thread-safe for our listeners who might be new to the concept.
Great point, Sheila. Thread safety refers to the property of a program or data structure that ensures it behaves correctly when accessed by multiple threads simultaneously. In simpler terms, it's like having a library where multiple people can borrow and return books without causing any confusion or errors.
Exactly, Victor. Now, to answer our main question. Yes, concurrent HashMap is indeed thread-safe. It's designed specifically to handle concurrent access from multiple threads without the need for external synchronization. But what makes it different from a regular HashMap?
That's a great question. A regular HashMap is not thread-safe, meaning if multiple threads try to modify it simultaneously, it can lead to data corruption or inconsistencies. Concurrent HashMap, on the other hand, uses a clever technique called lock striping to ensure thread safety while maintaining good performance.
Lock striping is an interesting concept, Victor. Could you explain it in simpler terms for our listeners?
Certainly. Imagine our library analogy again. Instead of locking the entire library when someone wants to borrow or return a book, concurrent HashMap divides the library into sections. Each section has its own lock, so multiple people can access different sections simultaneously. This approach significantly reduces contention and improves performance.
That's a great explanation, Victor. It's worth noting that while concurrent HashMap is thread-safe for individual operations, it doesn't provide atomic operations for put if absent, replace, or conditional remove across the entire map. Developers need to be aware of this limitation when designing their applications.
Absolutely, Sheila. This brings us to an important point about performance. While concurrent HashMap is generally faster than using a synchronized HashMap, it does come with some overhead compared to a non-thread-safe HashMap, so it's crucial to use it only when you actually need thread safety.
Good point, Victor. Let's discuss some common use cases for concurrent HashMap. It's particularly useful in scenarios where you have multiple threads reading and writing to a shared map, such as caching systems, producer-consumer patterns, or managing shared resources in a multi-threaded application.
Those are great examples, Sheila. One common misconception I'd like to address is that some developers believe concurrent HashMap is always the best choice for multi-threaded applications. However, if your application has more read operations than write operations, a copy-on-write array list might be more suitable.
Excellent point, Victor. It's crucial to understand your specific use case and choose the right tool for the job. Now let's recap the key points we've covered about concurrent HashMap's thread safety.
Great idea, Sheila. Here's a quick summary. 1. Concurrent HashMap is indeed thread-safe. 2. It uses lock striping to improve performance while ensuring thread safety. 3. It's suitable for scenarios with frequent reads and writes from multiple threads. 4. While thread-safe, it doesn't provide atomic operations across the entire map. 5. It has better performance than synchronized HashMaps, but some overhead compared to non-thread-safe HashMaps.
Excellent summary, Victor. For our listeners who want to dive deeper into this topic, here are 3 advanced areas to explore. 1. The internal implementation of concurrent HashMap and how it has evolved across Java versions. 2. Comparing concurrent HashMap with other concurrent collections in Java. 3. Best practices for fine-tuning concurrent HashMap for specific use cases.
Those are fantastic suggestions, Sheila. And that brings us to the end of today's episode of Crashcast Java. We hope you found this discussion on concurrent HashMap's thread safety informative and engaging. If you enjoyed the show, don't forget to subscribe for more Java insights. Until next time, happy coding!